Well, I want to thank you all for, I want to thank Deborah for connecting me with this exercise. She's really terrific. I hope you know that. And I also want to thank all of you personally for being here during the summer. I realize that's a huge sacrifice. You know, the comment about knowing my voice, I used to, whenever I would do these talks, I would wear the same outfit. So people would think I had only one suit of clothing, but I've gotten over that. So I'm going to be talking about the science and praxis of team science, because you can fund it as teams, so you'll be working as teams. And so basically I'm going to talk about three things. One is why bother with this? You know, you've worked with people since you were in kindergarten. What is there to learn? Why is there something to pay attention to? There actually is a body of science building up around the trying to optimize, trying to make teamwork successful. So we'll talk a little bit about that science. And then we'll get into what is sometimes called the praxis of team science, how to actually do it, the sort of practical know-how. But I want to start off with some people. Here's a picture of someone from the 15th century. Anybody know who this is? Leonardo da Vinci, yeah. So he did a few things. He painted the Mona Lisa. He taught us a lot about anatomy. He was an engineer, designed bridges, designed weaponry, and even built a flying machine. So he did a few things. He wasn't exactly siloed in one discipline. Here's another person from the early 1600s. Anybody know who this is? This one is Galileo. So he also did a few things. He looked at sunspots, described them. He made some major contributions to astronomy. He taught us a lot about gravity, built devices to measure temperature, learned a lot about inertia, all kinds of different fields. Put up your hand if you know anybody like this today, or even can think of anyone alive today who has this kind of breadth of contributions to knowledge. Okay, who is it?
Philosophy and Christianity, he's a clinician, a research scientist, a pilot, jazz musician, and he teaches a divinity school at Duke and bioethicist.
Okay, now if we think about, so that is fantastic that you know people like this. Now think about, will we know their contributions to science 1,000 years from now? Do you think? Will the person have left that kind of contribution? We don't know. Okay, let's hope so. Okay, we aspire to that. That's great. Any other historic figures or sort of nationally known figures? Okay, I raise this just because, yes, let's hope that will be the contribution left behind. But I raise this because I think it's pretty unusual. And one thing that has happened is we know a lot more. The bodies of knowledge have deepened. If you think about the number of publications that come out every day, even keeping up with the literature in your own field is pretty darn hard. To think about having a depth of expertise not only in your own area of science, but in other people's areas of science, enough to make major contributions to fields like astronomy, art. This is pretty difficult. This reality that it's hard for us to have deep expertise in all of the areas we need to know this has become a real challenge. Some people think that we have solved many of the easy to solve problems, and what is left are complex problems, things like global warming, things like poverty, cancer, fixing the healthcare system, and that really this is more than one person's expertise can fix. So we need complexity, we need expertise from different domains. And this is really what the science of team science is all about. It is the process of trying to integrate two or more very different scientific approaches to a complex, multifaceted project, to a problem. And you have all, I understand, been funded because this is what you're trying to do. You're trying to bring to bear expertise from different domains to solve a complicated problem in a better way than any one of you or any one discipline could solve it. Okay, so what is all this about a science of team science? Well, people began to notice that there were certain things happening in the sciences, and this is one of the major ones. What you're seeing here is the percentage of work that's being done by teams and the team size for people in science and engineering, the black line, people in the social sciences, the gold line, patents, and the arts and humanities. And what you'll notice is that in the arts and humanities, there really hasn't been much change. The percent of work that's being done in teams is still very low. The arts and humanities is still a place where you can have a solitary scholar. This really hasn't changed. It's fine. And team size has stayed pretty stable at 1. But in all of these other domains, the percent of work that's being done by teams, by more than one person, and the size of the teams is going up. And this has been going on for quite a while and seems to be continuing. I don't know if any of you have ever taken a look at publications in genetics, these mega multiple authorships. They're just massive. So this is an ongoing trend. So here are just some selections of particular fields where you can see this in action. So here you see in social psych, team size has gone up, in economics, ecology, astronomy. At least up until 2000, the average team size had now gone up to about somewhere between 3 and 4. But this is an analysis done by Brian Utsi, who does a lot of this bibliometric kind of work, looking at the size of the group that it takes to put on a Broadway show. And we've seen a similar trend where the size of the team it takes to put on a Broadway show continued to grow until it has now apparently stabilized at about 8. These are the sort of the movers and shakers behind getting a Broadway show organized. So there is some thinking that this may be a sort of a steady state. This is the optimum group size, at least for that undertaking. And people are trying to figure out in other fields of science, will it be 8? Will 8 be the sweet spot, or will it be more? We really don't know the answer to that yet. So why is this happening? Why is team size increasing? Well, part of the reason is, we need to know things that we don't know. If you are developing a new technology, you may be an engineer or a computer scientist or a biochemist, but you may be able to build the technology, but you're not necessarily going to be the person who knows how to market it. You're going to need people who have different skill sets and different training to do that. So this need to have expertise beyond our own is very real and increasingly recognized. In the hard sciences, there's the issue of needing access to large equipment. Equipment that is too expensive for one group to buy on its own. So this is another thing, shared resources, shared equipment, shared funding. These are things that bring larger teams together. wicked problems. These are the kinds of things I was mentioning earlier. Global warming, poverty, cancer. These are not simple problems. They may even be insoluble, but at the very least, they require some sophistication and depth in multiple areas. There's also a sense if we're trying to train our mentees for the future is going to be increasingly interdisciplinary. It probably is not going to look like things look now. For years, I've been going to talks where they would show the disciplines in the traditional academic disciplines as silos, and they would be blowing up and forming new disciplines. So now we no longer have only neurology and psychology, we have neuroscience. This is a whole new entity, and this is happening across the sciences. So in order to train for the future, we have to try to skate where the puck is going, and all we really know is that it's going to be different, and it's probably going to require people to have a broader breadth of knowledge. And I think the major driver, this is the one I hear from scientists all the time, is the issue of obtaining prestige and visibility and impact. So that's pretty lofty. And, when I think many of us, when we first think about it, it's like, yeah, you want to have impact, you just have to publish lots. So why don't you just go into your lab and just stay focused? Why would anybody think you would get anything more than chaos from trying to work with a whole lot of other people? Well, it's really because of the data. Again, we go back to the science of team science. And so what you see here is what's being plotted on the x-axis is the impact factor of these various projects and publications. And across the board, you can see here we're looking at social, psych, economics, ecology, and astronomy. By and large, impact factor goes up as the number of incumbents, the number of experts on a team rises. There is some concern that there is a ceiling to this, and they certainly encountered it in the Broadway arena. There's a point at which if you have too many old fossils on the team and you don't have new blood and new ideas, you may get blocked. But so far, it's been kind of hard to find that. We all believe you need newcomers as well, but the evidence is still emerging for that. Diversity, the tendency to repeat previous collaborations, if you're always working with the same people, that clearly is not a good thing. Impact factor goes down the more you're working with the same people over time. Team size, so far, the larger the team, the higher the impact factor. Again, we suspect there's a ceiling there someplace, but so far we haven't seen it. Another thing that's happening is not only are their teams getting larger, they're getting more geographically distributed. So here, the red line is single author or single person collaborations. You can see those are going down, again, everywhere in science and engineering and social sciences. They are the way of life in the arts and humanities, so they stay high. Within institution collaborations are flat. What's growing is between institution collaborations, the green line, in both science and engineering and in the social sciences. Why? Again, there's an impact advantage. Here what you see, where 0 is all things being equal, you do the collaboration within institution or outside, you see a bump up. And the bump up is particularly high for the social sciences. Now let me expand upon this a little bit and show you this. This bump up is particularly high if you have two top-tier institutions collaborating. Then you really see a bump up in citation impact. And it's sort of, it's gradated, it's sort of dose response. And this is an example of academic inequities. If it's two Tier 4 institutions collaborating, better not to do that because there's actually a decrease in impact. But I think that the message of this is if you can collaborate with a higher tier institution, go for it because the odds are good that it will increase the visibility of whatever it is that you're doing. So the other thing, of course, that is driving this trend towards team science and interdisciplinary collaborations is that the funders want this. They believe in this. They think this is the future of science, that the major breakthroughs will happen at the interfaces between disciplines. And so here you see this in action. If you look at 2010 total National Science Foundation funding, what you see is that in 1982, 88% of that funding was given to individual investigators compared to 12% given to teams. Now look at it for 2010. 38% given to individuals, 62% given to teams. The funding agencies are putting their money behind team collaborations. And now we look at NIH, which has about more than 4 times the budget. The big transition happened in 2003 with Zerhouni's introduction of the NIH roadmap, which was really seen as a fundamental shift away from supporting single discipline work to wanting to support this larger interdisciplinary work. And here's some of the timeline that lets you track how this change came about and how it was visible at the national level. So 2003, I think, is really when it sort of tipped. And you had came first from the bioengineering, the NSF-oriented sciences, which had this consortium on catalyzing team science. And then you had the NIH roadmap, which talked about these the teams of the future to solve complex problems. By 2006, remember NIH, we mostly know it as an extramural funding entity that funds our work, but they also have a large intramural division. And they tackled what has been one of the major challenges in fostering interdisciplinary team science. And this has to do with the promotion and tenure process. The promotion and tenure process has historically been oriented in a way that it rewards individual work. It wants first author publications, or in some places second author is fine because your students are first author, some places first or last author, but it's looking for evidence of independence. This is beginning to change, but it's been slow going. This has been a major barrier to trying to inculcate team science. Well, NIH made a major shift in 2006, and they revised their criteria so that they would reward team science out of recognition that you need some people who are going to be the glue that holds teams together, who collaborates to make this interdisciplinary work happen. At Northwestern now, we have a team science track, which is different than the clinician track, different than the research scientist track. It is in recognition that if you want collaboration, you need to reward people to do it. We then went on, we saw the next shift here happening with the formulation of the CTSAs, the Clinical Translational Science Awards. Many of you will remember that what was the predecessor for that was the GCRCs, the General Clinical Research Centers, where basically we put people in hospital rooms and we paid for their assays. The CTSAs was a shift to saying, look, we've now got to look at translation, we've got to look broader, we have to engage with the community. So this was a major shift in NIH funding. Other things that helped, you still had issues within the university. A grant comes in, who's going to get the indirects on it? So to address this problem, NIH shifted to having multi-PI grant mechanisms where there could be multiple entities that were getting the overhead. So, so we have evidence that teams have higher impact, that the feds are putting big money behind this. But then we also have findings like this. What this is showing is that, and this is a very widely cited finding by Cummings, the more universities you have involved in a collaboration, and remember that big bump up in impact with more universities, the less output you have. Huh? You want to have impact, you need output, right? So this is the other side of it. So it's very concerning. What we now understand this to be is that basically this is a team, multi-university analog to a phenomenon called Allen's Law. Allen was a management professor, did this work in 1977. And the finding is basically that when you have coworkers who are more than 30 meters apart, the effectiveness of their collaboration declines. What's going on? They don't bump into each other going to the water cooler or to the restroom. This is why some of the Silicon Valley firms put one restroom in the whole building, because people have to bump into each other to get to the facilities. So if this is what happens in small office spaces, why in heaven's name would we think that it would be any different when we have multiple institutions? So what seems to mediate this is, and this barrier can be overcome if the people doing these collaborations invest in what is called coordination activities. This means these things like blue jeans, conferencing facilities, getting together for meetings, committing to write joint papers. This is not going to happen by itself. We're all going to go and hide in our own individual offices. So if you want complicated collaborations to work, you have to remember there are people involved. And you need to move the cheese to get them to go meet each other at the cheese. So this is all sort of big picture talking impact factors, dollars, structure, architecture. What makes team science so challenging, really? You know, why is it that we think this is, whoops. Well, it's really this.
Can you read the caption?
The caption is, you have two guys sitting together talking, and the one of them says, sometimes I think the collaborative process would work better without you. And isn't it true? Well, isn't it so much easier to have control over your own deliverables? It's, you know, it's just, it's tough when you have to depend on other people. It's like our kids in elementary school talk about, they already know the term social loafing. They don't want to be assigned group projects because they know they're going to wind up doing all the work and other people are not going to pull their weight. So, you know, it's tough. Well, one thing I want to point out at the outset is that there are degrees of challenge in doing this, and you don't necessarily have to go the whole way. So you can think about this as being on a continuum. This is a spectrum that goes from low to high in terms of the level of interaction your team needs to have and the level of scientific integration you're aspiring to reach. At the low end, you can have unidisciplinary investigator-initiated research. You can have multiple investigators within a single discipline. That's hard enough for many people. You're working on projects where you know the vocabulary, you went to school in the same science. You still have to deal with multiple people, but basically you know the terrain. The next level up, and I think this is fun for many people, is a research collaboration that is multidisciplinary. In this case, the group works on a scientific problem, and each discipline brings a different expertise to bear. What usually happens in this kind of framework is the disciplines work separately, sequentially. They work, an example, one group builds the technology. They build the sensors, they program the computers, build the devices, and then they hand it to another team that actually implements the clinical trial, recruits the patients, and so on. This is really more of a multidisciplinary collaboration. You might think of it as each group works separately, and then they throw the product that they've developed over the transom to the other side to catch and do their thing. The responsibilities and roles are quite separate. It's like parallel or sequential play. The next level up is this interdisciplinary or transdisciplinary level of work. This is where things get really hard. Here, you again have the disciplines bringing their own separate expertise to the table, but now what they're trying to do is to learn enough about the expertise and knowledge base in that other field to actually be able to develop some sort of shared mental model so they can understand how this problem looks from the other discipline's perspective, so they can actually be able to communicate. You know, they're not going to go to graduate school in the other discipline, but often what happens is that they develop a kind of a pidgin language that lets them communicate. Often discussions of this kind of work, you will often hear, and I had an experience with the head of a cancer center and an engineer who were sitting down together to try to develop a joint problem. A joint project. They really couldn't understand each other. Finally, one of them drew something on a napkin, drew a visual diagram on a napkin, pushed it across the table to the other person, who nodded his head, drew something more on it, pushed it back. It is literally at this level of trying to figure out what in heaven's name somebody else is talking about, and going to a level. Often it's beyond words, it's beyond a sophisticated understanding of the science. But here, you really need a lot more collaboration activities. You need regular meetings. You're going to need to spend a lot of time talking because you're trying to do something much more ambitious. That's transdisciplinary and to a certain extent inter. Okay, so you've all got a team. So what should you now be thinking about at the practical level to get that team to function well, to optimize its performance? I like to think about this in 3 buckets. The first, which is what I've just been talking about, is the cognitive bucket, the sort of the mental bucket. Here, you're trying to manage people's ability to understand each other. You're trying to develop a shared mental model by clarifying a shared goal. What is it that you're trying to accomplish? How do you think about what stands between you and getting there? The big picture vision, the shared language, you don't want to be too rigid here. It's the big picture of where you're trying to get to. And you may not define it all exactly the same way, but even that effort of trying to get on the same page about where you're going is a worthwhile undertaking. And this is what we're going to have you doing today. The second piece I think of as structural or sort of managerial. There are certain things, nuts and bolts things you have to do to sustain the infrastructure to get the dialogue to happen that's going to let you develop the shared mental model. So you need somebody to work with each other's calendars, to coordinate that, to purchase the equipment that and the supplies that each of the groups need. You need to exchange information. You don't want one group working over here doing something and the other group has no idea what it is. You really need a clear understanding of who's doing what, of roles and expectations, because you can see that what you're driving at is you need to develop a sense of responsibility and accountability. You're trying to get this team to involve people who can count on each other. And you're going to bump up against things like sharing credit. Who's getting what out of this? And the reinforcers may be quite different. Your basic scientists may want to publish in one set of journals, your clinical scientists in another. Your computer scientists may not even publish in journals. It takes too long. They want conference papers. You have to understand the different forms of cheese so you can optimize these outcomes. And this is not going to happen by magic. It's going to happen by these structural activities that make that communication happen. The last bucket I think of is process. Now, remember, I'm a psychologist, so this is sort of a little bit mushier or squishier, but it is stuff that I think it helps to be aware of because it's hard. Communication is one of the processes. We don't talk the same language. That has to be worked on. Interpersonal dynamics. We were just at the Science of TEAMSCIENCE conference last week and heard some very interesting findings on temperamental characteristics of people in teams. And, so there are some people who are very detail-oriented, and they're very concerned about, okay, now we've got the vision, who's doing what, and how are we going to get this to happen? Well, and then there are other people who are just big picture visionary folks, and they really will get there somehow. Just let's make sure we're clear where we're going. You really need to optimize those two things so things can really go wrong if you've got the whole group trying to discuss the vision, and every 2 minutes the detail people are getting anxious and saying, who's doing that? So you need to balance these temperaments so that they can work well in a room together. These are process kinds of things. Conflict. It's inevitable, and I'm going to suggest to you it's absolutely necessary. There is a phenomenon called adversarial collaboration. There is actually a wonderful article by Kahneman, and it's I can't remember the other person's name. It's in the American Psychologist, and the gist of it is that we think differently. We come from different backgrounds and different assumptions. That's not a bad thing. That's something we're trying to encourage. So it can be really helpful to explicate where the disagreements are so we can understand more and from a different vantage point. So this may be something we want to encourage. Language, interdisciplinary, it's literally very concrete things like one person says mouse, and this is what he means. One person says mouse, that's what he means. And as we get more highfalutin, we can kid ourselves more about the fact that that same thing is going on. When I talk about an interaction and my epidemiologist colleagues talk about an effect modifier, it takes me 2 years to figure out we're talking about the same thing. But this is because we're so proud. We can't say I don't understand you. Developing a shared vision. How do you know when you're there? That everybody on the team can give some version of what's the big picture and how they fit in it. What is their unique contribution? What's their role? Then they're bonded. They feel needed and accountable, and they feel that other people are accountable to them. This is critical. And it's also really hard because it requires that people not only take accountability and responsibility for successes, but also for failures. Failure is inevitable when you're trying to do something this hard. And it needs to be something that people acknowledge and can accept responsibility for. Nobody's going to shame them about it, but we need to learn from this. Part of the process of building a better team, you need to learn from it and move on. And be glad that it happened, because you now know more than you would have if it hadn't happened. Okay, harnessing diversity. Why are we? So we're trying to bring all these different kinds of people together. Might be physician, a basic scientist, an engineer, and what we want them to gel into a cohesive, integrated team. Okay. Why? Well, diversity we have come to believe is a real asset because it brings insights and skills and experience that are developed in different terrains, and it lets us know more than we can as an individual because we only have one individual's experience or one discipline's experience. So if we can harness this, this becomes intellectual capital. We can think about this as sociologists do. And a sociologist would think about this as intellectual capital. There are groups of people who have this kind of knowledge and other people have this kind of knowledge. And the trick is to connect these people so that they have access to more bits of knowledge. You can think of this as, so this is a group that knows physiology, and this is a group that knows mathematics. And they know different things, but they don't talk to each other. They have no people in common. So this is a structural whole. The way the sociologist will approach this is they will try to find a way to bridge that whole. They will, because they see that it provides a vision advantage. It's like a broader perspective that you can't have as an individual. They think that what's needed is brokers, knowledge brokers, or connectors or integrators who can help do that. And we're going to have you identify these folks who may be in your network that you can bring to bear for your team. Now, that's sort of very abstract and mathematical, like a sociologist thinks about it. Now I'm going to show you a picture of a couple of teams that need to get brought together for a project. So here we've got a medical team. And here's your technology team. This might be very much for the kind of mobile big data to knowledge project that is being done here, where you're trying to build sensor technology to prevent readmission to hospital for congestive heart failure. What do you see as you look at these teams?
Lots of posturing. Your one.
Posturing. Okay. Look, formality. They're very clean. They're a little bit older. They have what's that? They have the God concept. Okay. So I guess people are more comfortable with this one. So and in this one, you can't even quite figure out who's the group leader. So this might be a tech team that just you're looking at extremely different cultures. And this was actually very nicely written about by Hannah Valentine, who used to be at Stanford, is now at NIH. When the very first time she tried to do something in team science, she brought together a medical team and an engineering team. And she brought the two teams together. They sat at a big long table, and she thought, they'll write a grant together. Brilliant. So the tech folks came in, and they looked a lot like these folks, and they sat at their end of the table, and they all argued with each other and talked over each other. Nobody could figure out who the leader was. They just, that's how they did things. Meanwhile, the physicians sat at the end of the table, and they thought, oh, that leader doesn't know how to lead a group. They immediately lost respect for them, and they didn't say anything. And then finally, Dr. Valentine called on them to speak, and the leader spoke, gave addressed the question that had been asked. No one else spoke. Very, very different cultural norms. So how do we see this? I live in a medical school, and I see this in the interchange between physicians and basic scientists. And these are really, they may not be so obvious as the clothing differences, but they really do wind up having a huge impact, and it really helps to understand them. It's easier to just say, oh, yeah, they're stuffed shirts, and but you have to work with them. So you have to try to understand why they are stuffed in that particular way. If you're a physician, part of your training is, there are lives on the line. You may need to take immediate action. If you are a basic scientist, you are trained to avoid a rush to judgment, avoid bias. You hear in the one case, don't just sit there, do something. You hear in the other case, don't just do something, sit there, reflect. Don't be misled, don't be impulsive. A physician is held to standards of practice. There are certain right ways of doing things that have been, they're based on research, they are carefully curated, there are standards of practice, and you don't want an overly creative surgeon. You want them doing stuff that is tried and true and well tested. On the other hand, if you're a basic scientist, we're trained to be mavericks. We are trained to challenge the existing paradigms. That's how you learn new things. We're rabble-rousers. We're troublemakers in that context. The physician is committed to certain oaths of professional standards. Basic scientists are committed to the truth. If you're doing a professional standard and it's not right, well, we should find out what's correct, what's right, what's the truth. Very different. You see, in the medical community, respect for hierarchy and expert authority and wisdom. We're trained to be rabble-rousers, to critique accepted wisdom. That's part of our training. Things look different when if you make a mistake, somebody might die. Versus the way I've talked to you about it, you have to make mistakes if you're going to learn. If you're not making mistakes, you're not stretching enough out of your comfort zone to be taking risks that will let you learn something. Physicians, medical community, trained to apply knowledge that other people has collected. We're trained to discover new knowledge. You see the difference at the level of the suits and ties versus the jeans and t-shirts. Okay. Other things that underlie this, and it takes a lot of discussion to start to get to this, but there are very basic differences in how we view the world, how we view science. One that I have always had trouble with, my training as a basic scientist said, look, I find the truth, I do research, I do not do advocacy. That's when I start to push the envelope and stretch the truth of my research. But the reality is we also have social responsibility. So that's a difficult one. And people tend to fall into one bucket or another. Questions about, is it possible to do unbiased research? Can you really get rid of your own perceptual biases? Can you find an objective truth? Another difference. What kind of data or adequate evidence? Is qualitative data okay? If I ask people's opinions about things and they tell me their opinions, is that okay? Different views. Reductionism. Can you take a problem like poverty and reduce it into its component parts, into dollars and cents, into physical characteristics of neighborhoods? Can I develop a smoking cessation intervention that I can do here in Memphis, and then I can go and do it in India? Will it be the same? Is it possible to have a truth that is independent of the context? We're socialized very differently in these things, and they sort of become a little bit like our religions. So what we want to do in putting together our team is to make a productive collision of viewpoints. We want people who see things differently, and we want them in a context where they can constructively explore these differences and look for solutions that will go beyond what they individually can see. And so we're always on this seesaw. We want to contain conflict enough that people can get their work done, but we also want to foster disagreement that will enable us to experience different ways of viewing a problem. This model is another classic. It's one you may find quite useful. It's the Tuckman model of team development, and it basically says there are stages of team development. The first stage is forming a team. Notice everybody and they're on their best behavior, all in their proper clothing and on their best manners. And wouldn't it be nice if we could stay that way? We agree about everything. Everything's hunky-dory. The only problem is we're not learning. And so the next stage is called storming. This is when conflict happens, when you start to realize that you really don't agree about everything. But, you know, it may be uncomfortable, particularly if you're not comfortable with conflict, but you do get through it. You get through and you norm around the fact that you respect each other as people, you can count on each other as people, and you will agree to disagree because you see value in the diversity of opinions. Then you really reach the ability to perform to your optimum capacity, and you get to decide whether you want to continue working together or not. Storming is necessary. It's absolutely necessary because it gives you a source of energy. If you're not doing it, it means you're not engaging enough to experience the diversity in your points of view. You really need to have it happen to get beyond the superficial level. Now, at the level deeper than that, you want to eventually get to something called trust. When we talk about trust, usually we're talking about it in marriages, families. This is sort of a big, a much higher emotional bar. At the level of a team, it basically means you don't have your own individual control over the outcome. You really have to, contribute to the team, and you have to count on other people to do their part. And this is hard because all of us who work on teams tend to have huge egos. We can be quite fragile, and we also can be naively optimistic. Now, what do I mean by that? Well, I'm just going to skip on to this analogy. So this is the sort of the extreme version of trust. Do we have anything like this going on a team? Well, probably not, but it may feel like this if you allow yourself to actually experience what the stakes are. So what's happening here? Well, we are people when we come into our team realities, and we tend to get emotionally off kilter in one of two ways. The first is we can be very attuned to loss. We don't want to lose face. We don't want to lose prestige and power. We don't want to cede control to somebody else. We're afraid of losing something, be it a body part in that analogy, or face. It's uncomfortable when you're at the top of your game to say, I don't understand what you're talking about. I don't know that feel. This is a loss of face. So we deal with this badly when we just don't want to go there. We don't want to have those experiences that require us to admit ignorance. The other extreme, and we see this as well, is that we want to just close our eyes and figure that we're safe. And this happens when people have undue trust in their collaborators, when they don't pay attention to things like authorship credit, who is going to be talking to the media, who is going to own the data. That's the other direction of bias. Fortunately, we have tools to deal with some of this. And so these are some of the things that you will be learning to do to address some of these challenges. You will be learning to address conflicts among goals. You will be working on things like collaboration contracts that will have you specify in advance all the ways that things could go wrong and what you will do about them. So at least you will have anticipated that. You may have difficulty finding funding and publication outlets because what you're doing is new and funding mechanisms tend to be conservative. But you will overcome that as well, partly because you're at the front line, in the vanguard, where the funders want to go. At the end of the day, when you've got an infrastructure that's working, you've got a clear vision, you've got balanced power, everybody is benefiting, you've got enough trust, you have sharing of credit and resources, you can communicate and understand each other at least moderately well. You have institutional support, your administration, your tenure and promotion policies are aligned, and you've been able to find funding tracks. Some of the resources that we'll introduce you to, you've already met a couple of them. One of them is this TEAMSCIENCE.net or COALESCE, which was funded by the NIH to try to introduce some of these concepts. This is another very important resource, a volume put out by the National Academy of Sciences just a couple of years ago, very widely cited, looking at the science of team science. This is one of my favorites. It's a team science field guide developed by Howard Gablin and Michelle Bennett. Howard was the ombudsman at NIH Intramural. It was really his job to sort of be the marriage broker for intramural research teams, and there are some really wonderful contents in there. This is another one. Anything you would ever want to know about team science is in this repository. This one is assembled by the National Cancer Institute. It's called the Team Science Toolkit. It has assessments, it has syllabi, curricula, everything is in there. And I'm going to stop now. Thank you for your attention and see if you have any questions.
Do you have experience with upper limit of team? So
In terms of number?
in the terms of number, so NIH produce something like the ECHO grant or something similar where they bring multiple cohorts together, and they have sometimes hundreds. And I learned it's the most difficult thing, and it's very unproductive. Is there an upper limit?
So the question was, is there an upper limit to team size? And I think the answer is that nobody knows. So I showed you the slide of the Broadway musical where they finally sort of saturated at a team size of 8. But this, I think we are still waiting to find the limits. You think about the Human Genome Project and how many people worked on that. Some of the international collaborations that are going on now, they're huge. I think the answer is we simply don't know. Yeah.
I have a related question. So I think in your previous presentation you mentioned the larger the team, the higher the impact factor, and then the other one you put there, another point put there is the consistency and the stability of the team, the lower impact factor. So my question is like whether you have seen some kind of studies people they actually putting one as an adjusting factor of the other, and to see if you consider both the size of the team and the stability of the team, what an impact factor will be.
So this is the kind of work that Brian Utsi does. I think one thing I want to mention about the stability of teams is that they label it the diversity, but really it has to do with repeat publications with the same people. And I don't know what the degree to which that fully reflects the stability of the team. I think we have broad brushes now. We can see that more is better. We suspect that there's a cap on that someplace. It probably differs for different teams and different people. We really don't know where it is. We know that doing the same thing with the same co-authors again and again is not going to work very well. We know that you need some diversity, that finding about incumbents, you need some incumbents, but I think really we're looking at observational data. to try to make inferences about what we should do in practice, and that doesn't always translate. It's a hard inference to make. I think we sort of know how to go wrong at the extremes, and we're trying to optimize. Some of the most recent stuff that's come out in this has to do with issues like the amount of novelty in new publications that's has high impact. I personally find those findings very frightening because it's a tiny little proportion. Our fields are conservative. We can't handle too much novelty. On the other hand, my advice to you as teams is, this is the sort of the aggregate generalized science knowledge. But what you really care about is your own team. I'm big on experiment. Try things, see what works. Evaluate your own process. You're not really like any other team. So do what's working for you. You'll know faster, and the knowledge will be more applicable to your own case. Yeah.
So Sarah, you mentioned the Alex law. That law is out. So the base of the law said, expenses larger than 30% and success, the way or success for their collaboration. What I'm thinking, because that is like decades ago, and then now people, we have Skype, we have all this internet, all those kind of things. So I just don't know if you have some data to try to show whether that kind of law still holds. So that's
right. So the question was about, does Allen's law still hold now that we have the internet and texts and all of this? And I think I think we continue to find evidence that face-to-face meetings are important, that they're necessary. We don't necessarily think that the frequency of them has to be so high, because we do have these supplemental modes of communication. Having said that, as somebody who does technology research, something I'm always very aware of is, yes, we create these new channels, but then they become saturated and become a problem in and of themselves. They create burden, so that the question of whether email communication is really as good as face-to-face communication, I think it's a proxy, but probably not as good a proxy. So again, we know we're going to be in states of change. We're going to have more ways of communicating. Face-to-face is still going to matter, but we're going to take advantage of these other new technologies too. Yeah. There was
my question was related to Alan's one also. Is it based on industry research or?
Yes, it's the business context. Yes, at management level industry. So this is your business school context. Yes.
What I understand from the presentation is that the term team science is essentially directed towards a working team or a team that is being formed for an individual, because the recommendation is that the team is only going to be sustained for 2 years, and then some members will go out, some new members will come in, because at a certain point of time, maybe 90% of the team members who were originally formed, they're gone.
Yes, so the question was about the duration, the lifespan of a team. Maybe you will get to a point where 90% of the original team members are gone. And I think that's a very astute observation and absolutely accurate. The way that I think we're thinking about teams, the funding agencies are thinking about teams, is that they exist to solve a problem. And if they solve the problem, why should they continue to exist unless there's a new problem? that comes up that they are optimized for. So no, this is not like a marriage where we hope it's happily ever after. This is really folks coming together to solve a problem, staying together as long as there's yield for that problem for everyone on the team. But no, you don't have to hold on to them forever if they're not working for you.
You have a number of nations that coexist all the time. And of course, that varies from discipline to discipline. And also, a problem may not be solved in the lifetime of the research. It's possible.
So the question is, what's the sort of the optimal size, optimal duration? And I think your point is again right on target. It's impossible to make a formula. So this body of knowledge is applied to teams that are going to be on a space mission. They're going to be together for as long as the space mission happens, and then they're not. There are other rapid formation teams that come together to solve a very quick problem. They are intended to come together quickly and then disband. So it's really, you want a team that is configured for the problem that it's trying to solve. Yes. So the question is about the measurement of impact. And by and large, I think you're raising what I infer is an implicit critique about is that the best way to measure impact. And I think it's really, I think it's a fair critique. It's in some ways like looking for your keys under the lamppost because that's where the light is best. We can measure citation impact. We have large bodies of data on that. So that's where the work has begun initially. There is a lot of work going on now to try to figure out other ways of gauging impact. The emphasis on what are called altmetrics. The emphasis on things like even looking at downloads from repositories, looking at impact on the community. I think we know these things are important. We haven't found ways to quantify them as well. That's an active area of work, and once we have it cataloged well, I think we might expect it to have more impact on how this work is being done.
So actually, question. So the measure is
Citation impact of the publications, right? Because and it's different. Again, different fields have different impact factors. So, for example, there are some cancer journals with impacts, I believe, like of 80 some odd. Whereas many other kinds of journals are in the teens, or an impact of 1 is considered that's the top journal in your field. So these sort of harmonization of what's a reasonable impact factor for your field, these are hard discussions at promotion and tenure. And you can imagine now when you've got people who are working in multiple fields, how do you have a sensible contribution about the value, the contribution of their work? It's hard stuff.
So maybe, Jasper, one last question, and then we're going to have to
get on. Yes.
I want to separate the team itself, the leadership of the team. So one of the things we have done is for our research innovation clusters here at the Praxis, we appoint 2 leaders in 2 different colleges to kind of foster maybe the collaboration that you talked about also. And then you can, at the same time, you can also have 2 leaders from the same discipline, or you can have 1. Can you comment about the leadership of this research process?
Yes, and I think a lot of the work, as you can imagine, some of this science originated in business schools, and the emphasis was on leadership. It took a long time to start having study of the team. So the most important thing I think we have learned about leadership is you don't have to be a certain kind of person. You can have charismatic leaders who just, they're very engaging, inspiring. They command loyalty from their team. You can have other kinds of leaders who really don't seem to say much at all. They facilitate their team members. You're asking about the disciplinary aspect.
I don't even believe in individual leaders involved on these teams. I believe multiple leaders, question very is, are multiple leaders more effective, especially if they're in the team of multiple disciplines.
And I think that, so the question is, are multiple leaders more effective? And I think you are in an area of creative exploration where there is no science to guide you. So I would say that it's the same, it's the version of evidence-based practice. Collect your own evidence, see what's working. If it's not working, tweak it.
Okay. I would like that in fine arts. I think that the arts have a lot to offer for this kind of discussion and conversation about team building. If you look at the way that an orchestra operates versus the way that a string quartet operates versus the way that a jazz group operates, those are all wonderful models of collaboration. And they've been developed and they've worked over many years. I was struck by your first comment about Leonardo da Vinci, where there was really no separation between the arts and the sciences. We didn't even have words for that.
Right.
And so I would encourage all my colleagues here. Andy's smiling at me because he knows that I say these things.
I'm surprised it took you this long.
No more, it's really interesting because you're soloists on a team.
Exactly.
Yeah.
That's
and
very
so the
interesting,
analogy
yeah.
is actually a very
Yes.
interesting.
Yes, so that's quite wonderful. So thank you for sharing.
So Bonnie, thank you.
Okay.